Okay, if you've ever sat at the kitchen table with a frustrated child staring blankly at a math worksheet, trust me, you are not alone. Today, we're going to discover how to transform everyday household items into powerful math tools for your kids, completely avoiding that awful frustration of rote memorization. In this explainer, we're taking the brilliant concepts of Montessori math and bringing them right into your living room.
So why do young kids struggle so much with math on paper? Well, it's a super common hurdle, and the answer is actually really simple. See, as adults, we already think in abstract symbols. When we see a number 5 on a piece of paper, we instantly know what it means. But young children, they still process the world physically. To them, a 5 on a page is literally just a strange squiggly line. They have to physically feel the math before they can even begin to understand the symbol. Here's our roadmap for today. We'll quickly look at what Montessori math actually is, the power of hands-on learning, the 3 natural stages of math, how we bridge the gap from tangible to abstract thinking, using everyday household items, and finally, how all of this raises fiercely independent problem solvers. Let's get right into it. Section 1. What is Montessori math? The logical and slow approach. You know the traditional drill, right? Flashcards, memorizing formulas on a page, totally abstract. But the Montessori strategy, it completely flips the script. Instead of forcing your kid to just stare at these confusing symbols, this method lets them physically touch, move, and feel the math using real objects first. It's an absolute game changer. So, by definition, Montessori arithmetic is this really intentional strategy that introduces numbers in a slow, highly logical way. It basically ensures that learning is grounded in doing. This lets kids grasp these core concepts at their own individual pace. By making math physical, you totally remove the pressure, and honestly, you replace it with genuine curiosity. Moving on to Section 2, the power of hands-on learning, engaging the senses. Look at this quote right here. It perfectly explains why physical play translates directly into deep academic understanding. Think about it. When a child just hears a math concept, they're probably going to forget it. If they see it, maybe they remember. But when they literally touch and physically manipulate it, boom, multiple pathways in the brain light up, locking that concept right into their long-term memory. Picture this scenario. Rather than staring at 3 plus 2 equals 5 on some boring worksheet, your child is physically moving 3 wooden blocks and placing them right next to 2 other blocks. They can actually feel that quantity growing in their hands. They're basically creating this little mini narrative of addition right there on the rug. And trust me, they absolutely will not forget it. Which brings us to Section 3, the 3 stages of math, the natural developmental progression. So how does this journey actually unfold? Well, there are 3 natural stages here. Step 1 is pure physical exploration with real objects. Step 2 is that crucial bridge, moving from those tangible items toward abstract ideas. And step 3 is total problem-solving independence. This aligns so perfectly with how a child's brain naturally matures over time. And here's the catch. You absolutely cannot rush them to step 3 without fully letting them experience step 1. All right, Section 4, from tangible to abstract thinking, bridging the gap. So why the number 3? Well, because this whole incredible process of mathematical discovery can actually kick off around age 3. Starting this early with super simple tactile counting lays an unshakable foundation. From there, you can slowly ramp it up to those more complex concepts by the time they hit elementary school. Think of this progression kind of like learning to ride a bike with training wheels, right? First, you begin with tactile counting of real things. Next, you visually introduce what addition and subtraction look like by actually combining groups of items. Then you build up to the big stuff, like place value, multiplication, and division. Those physical objects are literally their training wheels. They support the child until their logical reasoning is strong enough to balance those abstract ideas all on their own. Once they've got that balance, you just gradually swap out the tangible stuff for abstract thinking. Now for the really fun part, Section 5, using household items for math. Practical translation for parents. If you've ever walked into a traditional Montessori classroom, you've probably seen those beautiful, specialized tools. Teachers use things like iconic golden beads to make place value real, long wooden number rods to show scale, or these little spindle boxes. They are amazing. But listen, if you're a parent trying to do this at home, you totally do not need to buy expensive items to recreate that magic. Because you actually already have a super powerful toolkit right in your house. Check this out. Instead of golden beads, just grab a handful of craft beads or even buttons from a sewing kit. They are perfect for counting and place value.
Instead of fancy wooden number rods, just use your kids' building blocks or Legos. I mean, physically snapping 3 Legos together vividly shows a child that 3 is physically longer than 1. And instead of spindle boxes, just grab some pencils or everyday drinking straws. These simple, everyday things act as the absolute perfect bridge to abstract math. Which leads to our final piece, Section 6, Raising Independent Problem Solvers, the ultimate payoff.
Here's the thing. By encouraging your kids to manipulate physical objects, like those buttons and Legos we just talked about, we are doing so much more than just teaching them how to add. We're actively pushing them to look for alternative solutions, or sharpening their analytical and logical reasoning skills. Ultimately, we're fostering critical thinkers who are fully prepared to tackle real-world mathematical problems, and to do it with incredible independence. Because when they truly understand the why behind the math, the confidence they gain is just staggering. So as we wrap up this explainer, I want you to think about the next time you sit down on the living room floor to play with blocks. You aren't just playing anymore. You're actively building a mathematical foundation. So I'll leave you with this. How will the physical building blocks that you use with your child today build their advanced mathematical mind for tomorrow?